Hey guys, if you could please turn to 12.7 in your notes, explore similar solids. Alright, this is the last section of chapter 12 that we're going to be doing. Okay? Similar solids. When you have two solids of the same type, so like two cylinders, two spheres, two rectangular prisms, if they have equal ratios, like all their radii or their heights, they all have equal ratios, those are called similar solids. Alright? Solids of the same type with equal ratios, those equal ratios are called scale factor of corresponding parts. Alright, example 1. Identify similar solids. Tell whether the given right rectangular prism is similar to the right rectangular prism shown at the right. Alright, so this is the prism we're looking at. Let's look at A. Solution. The prisms are similar because the ratios of the corresponding linear measures are equal, as shown. The solids have a scale factor of... If we look at their lengths, this one has a length of 5. The other one has a length of 10. If you simplify this, you have 1 over 2. The widths, we have 3 to 6. Three to 6 simplifies also to 1 over 2. And the heights, 7 to 14. And this simplifies to 1 over 2. So because they're all equal, they have a scale factor of 1 to 2. Let's take a look at B. It says the prisms are not similar because the ratios of corresponding linear measures are not equal, as shown. So the lengths are 5 to 15, which simplifies to 1 over 3 if you divide top and bottom by 5. 3 to 9. This also simplifies to 1 over 3, but the heights, we have 7 to 14. This simplifies to 1 over 2. Because these are not equal, they are not similar solids. Alright? Okay, let's go on to page 2. Checkpoint. Tell whether the pair of solids is similar. Explain your reasoning. Okay, go ahead and pause the video here, and when you think you have the answer, hit play. Alright, these are the answers that you guys should have gotten. This one, they're not similar because they don't have the same scale factor. These two are similar because they have a scale factor of 1 to 2. Alright, theorem 12.13. Similar solids theorem. If two similar solids have a scale factor of A to B, then corresponding areas have a ratio of A squared to B squared. And corresponding volumes have a ratio of A cubed to B cubed. Okay? So, example 2. Use the scale factor of similar solids. Cylinders A and B are similar with a scale factor of 2 to 5. Find the surface area and volume of cylinder B given that the surface area of cylinder A is 96 pi square feet and the volume of cylinder A is 128 pi cubic feet. Okay, so using this theorem, the surface area of A to the surface area of B, we know that the scale factor is 2 to 5. Okay, if the scale factor is 2 to 5, then the area has to be 2 squared to 5 squared. I'll write that here. 2 squared to 5 squared. 2 squared is 4, 5 squared is 25. So, the surface area, we know that the surface area of cylinder A is 96 pi. The surface area of B, we're not sure, but we know it has to have a ratio of 4 to 25. Okay? So, if we cross multiply, I'm going to add a step over here. They don't really give room for it. We have 25 times 96 pi equals 4 times the surface area of B. Okay, let me get out my calculator. Alright, let's see here. Okay, 25 times 96, and then ultimately we're going to be dividing by 4. 600. So these cancel out, and then I end up with 600 pi. Don't forget the pi. That's your surface area of B. So the surface area of B is 600 pi square feet. Okay, let's take a look at volume. Once again, the scale factor is 2 to 5, so the volume has to be 2 cubed over 5 cubed. 2 cubed, 2 times 2 times 2 is 8. 5 cubed, 5 times 5 times 5 is 125. Okay, so this is what we're going to use. And then we cross multiply again. I'm going to write in another step. We've got 128 pi times 125. This equals 8 times the volume of B. I'm running out of room. There we go. And then ultimately we'll be dividing by 8 again. Okay, let me pull out my calculator again. We've got 128 times 125 divided by 8. 2,000. So this equals 2,000 pi. That's the volume of B. So 2,000 pi. So the volume of cylinder B is 2,000 pi cubic feet. Alright, let's go on to page 3. Find the scale factor. The two cones are similar, right? We know that they're similar. Find the scale factor. Okay, so the volume's A cubed over B cubed. Remember, if you know that the scale factor is A to B, the ratio of their volume is going to be A cubed to B cubed. Let's simplify this. The pi's cancel out. 108 and 256, those both divide by, let's see here. Both 108 and 56 divide by 4. 108 divided by 4 is 27. 256 divided by 4 is 64. So, this equals 27 over 64. Okay, if I were to find the cube root, think to yourself, what times what times what equals 27? This is 3 times 3 times 3. 64 is 4 times 4 times 4. So, A and B, this is 3 to 4. So the two cones have a scale factor of 3 to 4. Alright, checkpoint. Complete the following exercise. Alright, go ahead and pause the video here. Let's see if I can get, I guess just try this one first, and then hit play, and then I'll do the next one. Alright, these are the answers you guys should have gotten. Go ahead and pause here if you need to copy them down. And pause the video again. See if you can figure out these two. Or this one, I mean. Alright, this is the answer you guys should have gotten. Go ahead and pause here and copy it down if you need to. Let's go on to the last page, page 4. Compare similar solids. Okay, a store sells balls of string in two different sizes. The diameter of the larger ball is 1.5 times the diameter of the smaller ball. If the balls of string cost $4.99 and $1.49 respectively, which ball of string is the better buy? Alright, volume of the large ball. We are not given the volume of either of the balls, but we know that the diameter of the large ball is 1.5 times the diameter of the small ball. Okay, so if the diameter of the small ball is 1, the diameter of the large ball would be 1.5. We could also, if we wanted, multiply each of those by 2. And have 2 to 3 instead, which makes things a little bit nicer. 3 cubed, 3 times 3 times 3 is 27. 2 times 2 times 2 is 8. So, their ratios are 27 to 8. Now, the price of the large ball is $4.99. Price of the small ball is $1.49. Okay? Let's see here. This fraction actually does not simplify, but 4.99 is really, really close to 5. And 1.49 is really, really close to 1.5. Okay? And if you multiply each of these by 2, you get 10 over 3. Okay? So, let's compare the ratios of steps 1 and 2. If the ratios were the same, neither ball would be the better buy. Comparing the smaller ball to the larger ball, the price increases less than the volume increase. So you get more string for your dollar if you buy the large ball of string. Okay. And a better way of doing this, I wish they'd given us a little bit more room. The volumes have a ratio of 27 to 8. These have a ratio of about 10 to 3. Okay? If we were to try to get a common denominator here, let's say I multiply these by 3, I multiply these by 8. 27 times 3, that's 81. 81 over 24, and this is 80 over 24. Because this one is bigger than this one over here, you're actually getting more string for your dollar if you buy the large ball of string. Okay, so the large ball of string is the better buy, and that's usually the case. Usually when you get the larger quantity, you get a better deal, although not always. Alright, checkpoint. Complete the following exercise. Okay, go ahead and pause the video here, and when you think you have the answer, hit play. Alright, this is the answer you should have gotten. It's pretty much the same thing that we did up here. The larger block turns out to be the better buy. Alright, that's all. I will see you guys tomorrow. Make sure you guys do the quiz.